Hello everybody. I'm King from the Department of Statistics, School of Public Health, Jinzhou Medical University. Last class, we have learned the chapter 4 in medical statistics. We have learned something about the statistical inference. So in today's class, at first, let's review what we have learned last class. Last class, we have learned the definition of statistical inference. And we said that there are two methods in statistical inference. The first one is estimation, and the second one is hypothesis testing. So what is estimation, and what's the meaning of hypothesis testing? Estimation is concerned with predicting the values of specific population parameters. So that means we can use some special statistics to estimate the value of parameters. For example, we got a sample, and we can use the data of the sample to figure out some special numbers, such as X bar, which means the sample mean. And then we know that this sample is randomly drawn from a special population. And we also know that population means there are so many persons or so many individuals in that group. So this circle is the population. And we want to know the parameter of the population. For example, mu. That is the population mean. So if we really have the data of the population, that means if we can know the numbers or the values for each person or each individual in the population, and then we can calculate the population parameter. For example, we can get population mean. But most oftenly, we cannot know all the numbers in a population. So we said that most of time, population is unknown. So how can we do that? We can solve this kind of questions with the method of estimation. So that means we can use the number of X bar to infer the population mean. So we said that in last class we have two methods for the estimation. The first one we call it point estimation. So that means we just believe that mu equals to X bar. So that means we just use a special number to represent the population mean, which is unknown. So this kind of method is the point estimation, which is one of the two methods of population But we can know that the results of the point estimation is not very correct, because we said that sample is small, population is very big. So sample is just a small part which is randomly drawn from the population. So the number of persons in the sample is different with the numbers in the population. So these two numbers, x bar and mu, they must be different. So the method of point estimation is not very correct. But sometimes in our research, for example, we want to use the number of population mean. But actually we don't have that number. So how can we do that? At this time, we can use x bar to represent mu, because mu cannot be known, because we don't have enough number. So we just use x bar to represent population mean mu. So we believe that mu equals to x bar. So that is point estimation. So you will find that in our class, when we do some little quiz, when we don't know the population mean mu, but we know x bar, we can use x bar to represent mu. That means we can believe that mu equals to x bar. So that is the first method of point estimation. And the second one of estimation, the second method of estimation is confidence interval. We also use Ci to represent confidence interval. So confidence interval, that is a special range. This range can include the population mean. But we must notice that it doesn't mean this range can include the population mean at the probability of 100%. That is because the confidence interval is calculated with the data of the sample. And we just mentioned that sample is different from the population. So that means when we draw a sample from the population, we can use the number of the sample to figure out a special confidence interval. But from the same population, if we draw another sample with the same size, for example 20, we can get another confidence interval. So maybe these two confidence intervals, they are different. So we said that the probability of a special confidence interval, which includes the population mean mu, is not exactly equal to 100%. It must be less than 100%. So when we talk about the confidence interval, most often we call it 1 minus alpha confidence interval. And here, the number of 1 minus alpha we call it the confidence level. So actually 1 minus alpha, or we call it confidence level, that is a special probability. So that means this range has a probability of 1 minus alpha to include the population mean. For example, if 1 minus alpha equals 95%, we call it 95% confidence interval. That means here alpha equals to 0.05. So 1 minus alpha equals to 95%, right? And when we are talking about 95% confidence interval, that means this range will include the mu, but the probability of the range include mu is 95%, not exactly 100%. So when we are reading some articles, you will find that in most of the articles, there will be 95% confidence interval. So that is very useful method in statistics. Compared to the point estimation, this method, which is confidence interval, this method uses a range to represent the population mean, not just a special number. So here we can find that this method is more useful than point estimation. And the result of confidence interval is more correct than point estimation. So most often, when we are talking about the estimation of population mean, we use the method of estimation. Especially, we often use the method of confidence interval. Okay, so here, this is the method of estimation. In the last class, we have talked about another method of statistical inference, that is hypothesis testing. So what is the meaning of hypothesis testing? So hypothesis testing is concerned with testing whether some statement about the numerical value of a population parameter is consistent with the sample result. So that means in hypothesis testing, actually we don't need to use this method for estimating a special value of a population with the number of a sample. We want to know is if there is any difference between the populations. For example, here we have two populations. This is population A and this is population B. Now we want to know, is there any difference between these two populations? But we have mentioned that most often population is not known, it's not given. So we know nothing about the two populations. So how can we do that if there is any difference? we need to use the data of the samples. So what is the samples here? We draw a small part from population A, and we can get sample A. And we also draw a small part from population B, we get sample B. So sample A and sample B, they are given, or we can say that they are known. So we can use the data of sample A and sample B to compare if there are any difference between the two samples. So if we can find that there are some difference between the two samples, we can infer that there is difference between the two populations. So this method, we call it hypothesis testing. We have just mentioned about the definition of hypothesis testing. In last class, we have talked about the procedure of hypothesis testing. Based on the definition of hypothesis testing, we can know that the first step of the procedure is to make a statement. Most often, we call the statement as hypothesis. We have two hypotheses, that is, the null hypothesis, denoted H0, and HA, that is, alternative hypothesis. Most often, H0 means there is no difference between the two populations. So there is no difference between the two populations. That also means the two populations, they are the same. So we can use mu1 to represent the population 1, mu2 represent population 2. So H0 should be mu1 equals to mu2. So that means they are the same. There is no difference between the two populations. So what is the alternative hypothesis? We said that we need to make a statement, and then we need to prove if the statement is true or not with the data of the sample. So if the statement is not true, that means the opposite situation is true. So here our statement is H0. So that means the alternative hypothesis must be against H0. They are in opposite. So here HA should be not equal to. So that means not equal to, that means the two populations, they are different, they are not the same. There must be some difference between the two populations. But here, don't forget a special number, that is significance level, alpha. We use alpha to represent the significance level. So what's the meaning of significance level? Do you remember that? Last class, we have talked about what's the meaning of significance level. We need to make a special decision with the procedure with the method of hypothesis testing. And how can we know if H0 is true or not? We need to test the probability of H0. So we need a standard value. That means if the probability of this 0 is less than that standard value, we can reject H0 because H0, that condition, that situation, has very, very small probability to happen. So that means we don't believe that H0 can happen. So we need to reject H0. So that is the significance level. So we use alpha to represent the significance level. And most often we use the number of 0.05 to be the number of alpha. So that means if the probability is less than 0.05, we reject H0. So this is the first step of hypothesis testing. And the second step is to do some calculation. We just mentioned that if we want to make some special decision with the method of hypothesis testing, we need to compare the probability with the number of alpha. But how can we get that probability? We need to do some calculations with the data of the sample to get the probability. We use P to represent the probability. But how can we get P? Most often, we cannot get the P in a direct way. So we have to use an indirect way with the data of the sample. So this is the step 2. We need to figure out a special number. So that special number is test statistic. For example, today we will talk about a special method of hypothesis testing. We call it t-test. And all the methods of hypothesis testing is named by their test statistics. So here we call it t-test. That means the statistic in this method is t value. So here, this is the special number which can help us to make the decision, which can help us to get the probability, the p value. So here, this is the test statistic, t value. And we need to figure out this number with some special formula. For example, in t-test, the formula is like this. So this is the formula for t value. So we just need to put all the numbers from the sample, all the given numbers in the question into the formula, and then we can get t value. So that is the second step of the procedure of hypothesis testing. So the third step is to state the decision. So we said that the decision is based on the probability, the comparison of the probability with the number of alpha. So here we need to get the p value. So how can we get the p value? We need to use the number of t value, which is calculated in step 2. So here we can use the t-table to get its corresponding probability for each number of t-value. And then when we get the p-value, we can compare the p-value with the significance level alpha, which we established in the first step of the procedure of hypothesis testing. And the number of alpha is most oftenly 0.05. So we can compare these two numbers, and then we can get the decision of this hypothesis testing. And here we said that there are two kinds of calculations. Two kinds of conclusions in hypothesis testing. The first one is when p is bigger than alpha. That means the probability of the sample, or we can say the probability of H0 is very big. So we don't have enough evidence to reject H0. So at this time, when p is bigger than alpha, we need to not reject H0. So that means H0 is true. So that means there is no difference between the two populations. But in medical statistics, we often call it there is no significantly difference between the two populations. So this is the first kind of conclusions. And the second one, what can I do if p is less than or equal to alpha? So that means the sample, or we can say H0, has very small probability to happen. So that means we can just take an imagination. If something has a very, very small probability to happen, in our medical statistics, we believe that that thing is not exist. So that means that kind of things cannot happen in medical statistics. So that is a rule for medical statistics. So when the sample has a probability which is less than alpha, we believe that cannot happen. So we need to reject H0. We need to reject H0. So if we reject H0, that means the two populations, they are not the same. So we can say that there is significantly difference between the two populations. So that is the procedure of hypothesis testing. And this time, this class, we will talk about some special method for hypothesis testing and estimation. So today we will start a new part in medical statistics. That is chapter 5. And the title for chapter 5 is One Sample Statistical Inference. And we have already know that there are two methods in statistical inference. The first one is estimation, and the second one is hypothesis testing. So here we will talk about these two methods in chapter 5. But these two words are very important. One sample. So what's the meaning of one sample? That means in the questions of chapter 5, there will be only one sample. So how can we know how many samples in a question? We can use the number of sample size, the little n, which is sample size. So if we can find only one number of little n, that means there must be only one sample. But here's another question. We said that hypothesis testing is used to identify the difference between the two populations. But if there is only one sample, how can we do the comparison? Because comparison needs two parts, right? A and B. But if there is only one sample, how can we do that? Do that kind of comparison. So we need to know that one sample that's very special in medical statistics. That means there is only one sample in the question, but in the question there will be a given population. That is given in the question. So what we need to do is to compare this sample with the given population. So we can find that in the question there is only one number of sample size, and we can get another one that is a given population. So when we are trying to solve the questions of one sample statistical inference, there must be some useful information in the question, and the informations include the data of a single sample and the data from a given population. So if we can have these two kinds of informations, that must be one sample statistical inference. Okay, so that's what we will learn in today's class. So the first part is one sample test for the mean of a normal distribution with known variance. So here that is very special in this title, because we can find that the method is one sample test. And we have mentioned what's the meaning of one sample. So in chapter 5, we are talking about a special method which is used for one sample test. We can call it one sample test because these methods are used for the comparison of a single sample with another given population. So we call it one sample test. And there is another key word in this title. That is with known variance. Variance. So what is variance? So do you remember that? In chapter 1, we have talked about the variance, right? In statistics, we use sigma square to represent variance, and variance equals to the square root. Variance equals to the standard deviation square. So that means standard deviation is sigma. Variance is denoted sigma square, and standard deviation we use SD for short. So SD denoted as sigma. So we can find that variance equals to standard deviation square. So that means standard deviation equals to the square root of variance. So here we will find that this keywords with known variance. If variance is known, variance is given in the question, that means SD is given 2, because square root of variance is SD, standard deviation. So here, that means this kind of method, one sample test for the mean of a normal distribution is used when we know the variance or we know the SD, standard deviation. So at this time, we can use the method of z-test. So that is the name of the method which is used for one sample test for the mean of a normal distribution with known variance. We call it z-test. So that means this title is actually the precondition for z-test. So z-test is used for one sample test and the mean of a normal distribution, and when the variance is given or the SD is given. So at these conditions, we can use z-test. So what's the meaning of normal distribution? The mean follows a normal distribution. What's the meaning of that? I will explain that later when we are talking about the t-distribution. So here, let's talk about the z-test for hypothesis testing first. And we have mentioned that last class, all the methods of hypothesis testing follows the same procedure. That is step 1, step 2, step 3, what we have mentioned. So step 1 is to establish H0, HA, and alpha. And step 2 is to calculate the test statistic. But please notice that this method is z-test. So here in step 2, we need to figure out the z value. So how can we get z value? We need to use a special formula. And this formula is what we have learned in chapter 2 in the normal distribution. So we can find that we use this formula, we can get z value. But maybe some of you will find that the formula is different from the formula in chapter 2. In chapter 2, we have learned the formula for z value, that is x bar minus mu over sigma. This one is different from the second one. So what is the difference between these two formulas? So now let's think about this. This one is used for the original data x. X follows a normal distribution with mu and sigma. But this formula, I think we have explained the central limit theorem in last class, and we said that when we draw a sample from the population, we can get X bar. That is the sample mean of the sample, right? If we repeat the randomly drawing, we repeat again and again, and we can get so many numbers of X bar. And we will find that X bar also follows a normal distribution with the same mu but different sigma. And we find that the sigma is actually sigma X bar. And we have mentioned that sigma X bar is actually standard error, SE, standard error. That is sigma X bar. And sigma X bar equals to sigma over square root n. N is the sample size. And sigma, what's the meaning of sigma? That is the standard deviation of the original data X. So here we can find that X bar also follows a normal distribution. So here in the formula in chapter 2, we can use this formula to get the formula in chapter 5. So here, this is the original data X, but now we need to change X into X bar. So here, this is not X, this is X bar. So this one mu is the population mean of original data X, but here is actually the mean of X bar. So it's mu X bar. And we said that X bar with X bar has the same population mean, so it's still mu. It's not changed. And this one, sigma for X. But now we change X into X bar. So here we need to change sigma into sigma X bar. And then we will find that we get the new formula in chapter 5. So that is how can we get the formula. So here we use this formula of z value, and then we can figure out the z value with the data of the given sample and the given population. This mu, we can find that it's not mu, it's mu 0. So what's the meaning of mu 0? That is the population mean of the given population. We said that when we are trying to solve a question about one sample test, there will be a given sample and a given population. So here, X bar is the mean of the given sample, and mu, actually, it should be the population mean of X bar, but which is given in the question is actually the sample, not the population of the sample. But let's go back to step 1 here. When we are talking about the H0, the null hypothesis, that means there is no difference between the two populations. The first population is which is given in the question, and the second population is the underlying population, the population of the given sample. So here we use mu 0 as the given population. We use mu to represent the underlying population of X bar. So here H0 means there is no difference between the two populations. So that means mu equals to mu 0. So let's think about this one. This one should be mu. But if we suppose H0 is true, mu equals to mu 0. So here we can use mu 0 to represent mu. Right? Okay, now my question. We have mentioned that in hypothesis testing, we use there is no difference, or mu equals to mu0, mu1 equals to mu2 as the null hypothesis, and we use not the same as the alternative hypothesis. So can we change that? Can we change the two hypotheses? That means can we use no different as alternative hypothesis, and we use not the same as the null hypothesis? Can we do that? Actually, we can't. It's not correct, because please notice that the result of a hypothesis testing must be based on the H0. That means we suppose H0 is true, and then we do the calculation. So if we use not the same as the null hypothesis, and then we cannot know the number of mu. So we cannot use mu0 to represent mu here. So if this number is not given, we cannot figure out the z value. So here, please notice that we need to use equal as H0, not equal as HA. Both of these two statements, they cannot be changed. That's very special. Okay, so here, this is the step 2. And step 3 is to get the P value was the data of Z. So here, how can we get the P value, the corresponding P of the Z value? We need to use the appendix table A1. So do you remember that? Last class, we have talked about how to use the chapter 1, the table A1 in chapter 1. And I think Teacher Gao have taught you how to use that table too. So with the help of appendix table A1, we can find the probability, the P value for Z. So the rest of the things are the same. We need to compare P with the number of alpha. And then we can make the series of rejection or not rejection. So that is what happened in one sample test. Actually, that is what happened in Z-test. And Z-test is used for one sample test with known variance or known standard deviation. Okay, let's take a few minutes break.